These are machine learning books, and most of them have something in common. This is where we are when we start our careers in machine learning. And this here is our goal. This is where we want to get. And the gap between these 2 points is made up by a bunch of different skills. The problem with most of these books is that they teach you one particular skill to close that gap. They're very heavy on theory and very light on experiences. And that's where this book, the Kaggle Book, comes in. This is a book full of practical advice. I even wrote this here. So I decided to reach out to the authors of the book. Here are the authors, Conrad and Luca, and asked them to share with me their 2 favorite lessons. I heard them out, added my own thoughts to the list, and came up with my 5 favorite lessons from the Kaggle Book. And we're gonna be talking about them right now. And let's start with lesson number 1. Data makes the difference, not the model. In real world applications, usually the difference between a model that works and what that doesn't is the data, not the model itself. Now listen, here I'm not talking about more data, I'm talking about better data. Every single model out there has the ability to start with features and turn them into predictions. And of course, there are differences between models and you can pick a good model or a bad model, but generally speaking, better data will have a much stronger impact on your results than a better model. I want you to keep this in mind whenever you're deciding how to split your time or where to focus next. Of course, every problem is different and there are no silver bullets in this business. This is a bullet, it's just not a silver bullet. But most times you should be able to squeeze a lot more value by improving your data, not necessarily by focusing more time on your model. And I'm gonna take this one step further. When you bring many people together, when you put together teams and give all of them the same data and ask them to create the best possible solution, something comes up to the top, something becomes clear. The key, the differentiating factor among all of those people is what you do with the data, how you handle it. And that brings us to lesson number 2. Improve, keep working on your feature engineering skills. This is something that many data scientists ignore for too long. And I get it, feature engineering, it's hard. It requires a ton of practice and a ton of creativity. But if there is something that will make a difference, it's your ability to start with raw features and turn them into signal, turn them into valuable information for your model. Guess what? The real world is messy. Companies right now, they're capturing data or planning to, or they already did, but none of that data is stored and transformed in the way you need it. So the first day on your job is your responsibility to transform that data and create, extract from that data valuable information so you can actually solve useful problems. And that's related to something the book mentions, a common mistake newcomers make. They immediately jump trying to build a new model when they in fact should put their time trying to understand and improve the data, the raw material they have access to. So yes, data is key. Better data is better than better models. And the way to get to better data is through feature engineering. With those 2 out of the way, let's make a moment of silence for those of you watching this video that haven't subscribed yet. Now is the perfect time to click that subscribe button before we go straight into lesson number 3. Set up a solid evaluation process. I talk to a lot of people and I always give them the same recommendation. Don't start until you understand how to evaluate the success of your project. There's always a specific criteria to evaluate the work you do. It doesn't matter what the problem is. You need a process to understand and optimize your work. So even before you start, ask yourself, what does success look like? What's that metric I need to optimize? Now keep in mind, every time I say this, people immediately think about a technical way to evaluate a model, like their accuracy or precision or recall. That's important, it's just not what I'm talking about right now. Here I'm going beyond that. I'm thinking about a way to evaluate your solution from a general point of view. Like, is your work any valuable? Is your work better than the existing manual process the company already has in place? Or are you solving something that hasn't been solved before? And these are not questions that you ask only one time. You need to keep asking them, and that's why you need a process to constantly evaluate where you're at. And this, of course, is the perfect segue to lesson number 4. Systematic experimentation is key. So you already have a good evaluation process. Now you need to start experimenting. It's very unlikely you'll find the best solution for a problem the first time you try, or the second time, not even the fifth time. You need to experiment relentlessly. The more you experiment, the more likely you are to crack the problem. I come from a software engineering background, and something that I've always found interesting is that when building software, you constantly find problems where you can go from zero to solve. There is the line that when you cross, your problem is done. Here in machine learning, you don't find those problems too frequently. It's all about continuous progress. It's all about good enough solution. And the way you improve, the way you move from where you are to a better solution is constant experimentation. But keep in mind, it's not only about the quantity of the experiments you run. You just don't want to throw spaghetti to a wall and see what sticks. You need to fail fast, and more important, you need to learn from it. So before you design experiment number 2, you need to think long and hard and learn from your previous failures and your previous successes. And that brings me to the final lesson. Lesson number 5, the one nobody taught you before. And that's assembling gives your model superpowers. Here is my conversation with Luca, one of the authors of the book, and it's funny because he mentioned 2 things. And the first one was about data and the importance of data over model and the importance of feature engineering. And number 2 was stacking and blending. And he used the word, he's the one saying they give your model superpower. And that's true. This is something that took me a long time to understand. But one of the most effective strategies in machine learning is using not one, but many models in order to make one prediction. So instead of trusting the results of one model or another model, we're gonna put them together and we're gonna use their combined power. The main idea here is that as long as these models tackle the problem from different angles, their combined result is going to be better than the result of any of the individual models. So when you're designing your solution, instead of thinking about this or that, start thinking about this and that. And of course, these lessons are just the tip of the iceberg. You see, I had a great machine learning professor that taught me way before I knew any of this, how to interpret learning curves. This here is a video you don't want to miss. It's been years and I still use learning curves every single day to understand how my models are doing. I'll leave you with that. Go nuts, build something cool, and I'll see you in the next one.